Another important term, crucial term, is isostenuria. So who knows what this means? What does it mean?
Isotonic urine.
With what?
Increased urination.
Yeah, it could
Increased
be.
urination of isotonic urine.
Yeah. But with what? With plasma. Even better, if we're talking about isotonicity, you're right. But even better, and I'm going to like more clearly explain what is specific gravity. So this is about density and density of plasma or blood and density of urine. And what is specific gravity? You know, of course, osmolarity, specific gravity, they are very much related, but it's about density. And how do you count specific gravity? Specific gravity is actually, it's a ratio. It's a ratio of density of any object divided by density of water. That's the classical specific gravity. And you know that the density of water is exactly 1,000 kilograms per square meter. So basically, if you want to know the specific gravity of gold, for example, the gold is, and I don't remember it exactly, but let's say it's about 1,500 kilograms per square meter, or I think it's 300 maybe, okay? And you just divide it. So the specific gravity is 9.3, okay? So that's for gold. And the thing is that there's a special feature. Let's say if it would be, for example, specific gravity of ice, okay, so ice. Of ice. That is, again, the density of ice, and you know, density of ice is actually smaller, lower than water. So it's like 920 over 1,000. So specific gravity of ice is 0.92, okay? And the thing you should remember is that if the specific gravity is below 1 compared to water, it has to be floating, okay? It has to be floating. It has a smaller density, so it has to float in water. And that's why ice floats in water. And the funny thing is, and that's why the books use specific gravity, because look at that. This is 92, so this is 92%. And it tells you exactly how much of the ice should be under the water, 92%, and you see only 8%. Okay, so it's floating. And how much this floats, if you would use any other object, if you put it into water, if it's floating, of course. If the gravity is more than 1, it goes down because it's going to go under the water, and that's it. But if it's below 1, it's going to be floating, and exactly the percentage tells you how much of the, let's say, whatever, of a cylinder is going to be submerged. So I won't go so much in detail with this more, but the idea, and I'll give it with water, okay? But it just works the same way. You don't have to use specific gravity for water, or you can put whatever there. You can put urine there, or whatever, okay? Yeah? And this is what they use at the IC unit, actually. The thing, they pour a urine here, and they have a special object that is floating depending on the density of the urine, okay? So how much it floats, or if it goes down. If it's going to go down, you know that the urine is not concentrating too much. It has a low specific gravity. If it floats up, you know it's concentrated, that the patient is able to concentrate. Get it? Watch out, you have to recount it for the urine, okay? But anyways, the point is that with this measurement, and nurses have a really easy way how to tell if the patient is concentrating urine or not. Although you would have to sort of count it for urine, but if you use the same ratios of the densities, although it was done on water, it doesn't matter because it works the same way. Yeah, you can put urine here. You can put whatever, oil here, okay? Doesn't matter, but it will tell you if it floats or not. So, with the same logic, you should know that the specific gravity of plasma is 1.011. So to water, it's higher. You know that the density of blood is higher than water. Of course it is. So if you have an object that has this density or this specific gravity, and you're putting it to the urine, you will see how much it floats or not. Okay, get it? So isostenuria means that you are peeing urine that has the same specific gravity as plasma. And what does that mean? It means that the kidneys are not functioning right. Isostenuria means pathology. It means it rings the bell. It tells you, watch out, I should check the kidneys. This is not good. This is serious. And it could be even more serious. And before we go farther, the thing you have to understand is that, watch out, I'm not talking about you and me, like that you take once, urine and suddenly it has the same specific gravity, because this can happen anytime. It just depends how much you drink and how much you eat ions, okay, how much you salt. Yeah, you salt. So by coincidence, yeah, many times in a day you can be isostenuric. Over here, I'm talking about a patient which has continuous isostenuria for several days. That's the bad thing. So the thing what I want to say is, normally, if you take urine and you're healthy and you're drinking a lot, during the day, it changes the specific gravity, and sort of it can go, from 0.03 till 1.040. It changes like this. So it goes below the specific gravity of the blood or plasma, and it goes over. Of course, in most of the day, here's 1.011, that's the most of the day, you are not drinking too much, so you're going to be concentrating urine. So it's going to be above, you're going to have increase, you're going to be over with your urine. But if you're going to now decide to drink 2 liters and more, you're going to get below and you're going to really get rid of water only. Get it? So this happens during the day, up and down, up and down. If you're dehydrated, of course, you're going to concentrate. So the specific gravity is going to be higher, over 1.011. But if a patient comes and continuously he's getting rid of urine that is all the time isostenuric with plasma, it's a bad sign. And it's a bad sign, I'll tell you already, it's a bad sign of acute kidney injury. So, first of all, when there is isostenuria, think of acute kidney injury. There's a functional problem. I'm not telling you that, but mainly it is. It could be already acute tubular necrosis, what's happening now. Because the epithelia are not working as they should and you're not able to concentrate. It goes just through the tubules without resorption. So that's isostenuria. And this can happen in kidney problems, or also tells you that the kidneys are not functioning well. And actually, the patient has to really take care of his or her kidneys and shouldn't do anything that could suddenly destroy them. And what could suddenly destroy them, for example, is dehydration. Because they can have sudden ischemia, just a bit smaller perfusion, and suddenly they get into acute tubular necrosis, like all the way. And this is a question which many MCQ question ask is, and so the isostenuria is obviously with any problems with kidneys, Or in other way, there is also one inherited disorder, and it's combined with malfunction of kidneys. And these people, since birth, they are very much losing urine, which is pretty much isostenuric, very near that. And it's sickle cell trait. Remember that. It's the heterozygous who has sickle cell. These guys, they don't have problems with anemia. They don't have these attacks of sickle cell attacks, which is thrombosis and MI and stroke. They're fine. They're actually protected against malaria. So they're just carriers. Okay, they're carriers. But these guys typically have isostenuria. And the thing, when someone comes to you and he has a sickle cell trait, always, typically they have isostenuria. And the thing, what they have to watch out, they always have to be well hydrated. They shouldn't do marathons and these things, certainly not, because they can suddenly kill their kidneys if they get dehydrated. So typically, remember, in acute tubular necrosis, that can happen to any of us if we have ischemia of the kidneys, or if we have the toxin, or if we have a combination of these two. Yeah, in one of the phases, we can have isostenuria over there for a while. Or from childhood, if someone comes to us as isostenuria, very likely he could have a sickle cell trait. Okay? Or sickle cell trait. So that was isostenuria, a very important term. Questions now. So, thanks for watching, and don't forget to subscribe and ring that bell. And as always, check the description below for supplementary questions and other materials.